So once you are into the material library, you can choose what material you are going to assign. So first what you are doing, we are going opening the file we want. We have selected the file as base one. This is one of the part in a plumber block, and we have took that part inside the diagram. Once the part has come inside the diagram, we are going into the we are going to assign the material property for each and every part. So we are going to the file, manage files. We are going to files, manage files, prepare. So file, prepare, you have the model properties. So you have got material, relationship, tolerance, tools, shrinkage, all details are here. So now we will start assigning the material properties one by one. So material property is not assigned. So you go to change. Now we are come to the material library, and the material library we see which material that we are using, and so create new material. We are going to create a new material. So we are creating a name for the new material. Create new material. So it is cast iron. The name of the material we gave is cast iron, and the description is body. So density of that cast iron, Poisson ratio, we are assigning the value for Poisson ratio. So this is very helpful because this Poisson ratio, Young modulus, and all these properties that is assigning the strength of the material will be assigned to the material, and when you go for the analysis, you need not give constraint again. Automatically it will take it from here. So, and also when you're preparing the bill of material, the material properties will be taken from this. So it will be easy for us. So now the material cast iron is assigned, and the Poisson ratio and Young model is also assigned. Now you go to open, go on to the next part, bearing. Next part is bearing. We took the next part out. Now we are going to do the same thing. File, prepare, model property. File, prepare, model property. Model property again we are going to change. We are assigning a name for the material. So gunmetal. Giving us a gunmetal. So generally for a bearing we use gunmetal. Since it is a heavy load bearing, gunmetal will be very useful. And Poisson ratio, Young's modulus, also assigned for that particular part, and then we are saving the model. So now we can check it out. The material property of that is assigned. So now we are going into open, file, then again open, and take the next part. Bearing 2 we got. So file, prepare, model properties. So model property is opened. Now again, if you are not taking the property from the library, we are giving a separate name for the property. So name of the material that we are using, gunmetal. You can give the description of the part, what is the name of the part or the use of the purpose application of that part, metal, and then the Poisson ratio, Young's modulus. So save the part, and you can check it out. You can, if you click, you can find out the properties. Whether you check whether your assigned material name and properties are already assigned here. You can check it once before you proceed. So gunmetal, it's there. So we are bearing instance, bearing as a name. So again we are opening the next part, bolt, opening the part in the directory. So now it has bolt has come. Go to file, prepare, model properties, change it, give the name for the material. So mild steel is a material used for that bolt. So name of the part we keep it as bolt, and now write the Poisson ratio Young's modulus for the mild steel, and then save the model. Now if you go OK, you can see here your properties will be seen here. So we are taking the next part and repeating the same procedure again. Model properties, changing the model property, assigning the name of the metal, it's cast iron. So you can give the description of the use of that cap. It's a used cap. So cast iron's Poisson ratio, Young's modulus, you record here. Once you record here, you can see it will come here in the library, and if you press OK, you can see this details. So again we are going to the new part, opening the next new part, and nut, preparing model properties, assign the name of the material. So mild steel is used for this. So name of the part, nut, and write the Poisson ratio and Young's modulus of the mild steel. So this is the last part we are assigning the properties. Again it's a fastener, so mild steel, and Poisson ratio and Young's modulus we provide for the mild steel, corresponding to mild steel. So everything is set. So values or material properties are set for all the parts. Now we open the assembly. So the assembly is open now. So you can see the entire assembly here. You go to exploded view. You go to exploded view here. So you can see the parts exploded here. This is very useful. Edit positions. You go to the edit positions there. In exploded view, you have the edit positions where you can relocate and check. So edit position is actually the tool that we use. You can see here here it is to edit the positions and check. So you can move it axially on 3 direction and edit the position and verify, so that you can how the it is mating and the movement of the object in different axes can be ascertained. So if you again click the exploded view, it will be assembled. Okay, here if you click the exploded view, again it will be assembled. Edit positions, again you can edit it. So you go to files, new file, drawing. Now we are going to create the drawing. Okay, so we are going to create this in the drawing sheet. So file, new, and we are not going to sketch part, sketch. This and this we have done already. What we are going to do now is a drawing. Represent this solid model in the drawing sheet. So we have, we put some name for it for the drawing sheet. So plumber block is a name that we give for the assembled drawing sheet. So plumber block. We have got what is the page position, portrait or landscape we choose, and what is the size of the page also we can choose. The size, once you choose the size, that size is come. Since it's a portrait A4 we have chosen, it has come like this way. Go to table, table, go to table, and you take the required number of box required for the sheet. So we take three columns and put it there. Insert the 3 column over here and click the first cell, and you can start typing it. This is the tool. This is where if you click this, you will start typing it in the block. Here, this is the tool for typing. So now you go to the next serial number and description of the part. Material, what material we are going to we have used in this assembly. So this is required whenever you are giving the sheet to the vendor. This is very important. Table. So we can adjust the height and width also. Here you have got, if you go to table height and width, you can adjust the height and width here. See, this will promptly appear here in the screen. Here you can adjust the rows, column and all. Now we increase the width of the row to 1.5. So width of row is increased. So based on a requirement, you can do editing. Width of the characters, anything, if you whatever you want. For example, the viewers, it should be comfortable to read and it should appear correct. So you correct it accordingly. Now you select it. Switch symbol. Here it is. There is a tab called switch symbol. So using that add repeat region. If you come to this switch symbol and come to this cell and take a right click, but add repeat region. Okay. Add repeat region. Switch symbol. So this is a region. Cell table. Report symbol. So index. Repeat once again. Go to report symbol. So add repeat region we are creating. Switch symbols. So the entire region is taken as a single cell in the table. So clicking this, here there are some report symbols. So this is, you have got to get the serial number. So repeat index, rpt dot index. So here assembly name. So first thing here repeat index, here assembly name. Then you can enter the symbol text also. asm.mbr description like that. Assembly member description. So mbr is a, so this is a very important step. You should do it correctly. So once it is if you do this automatically, the already assigned material properties and description that we have already given, all this will come here. That is the main purpose of doing this. Okay, so here serial number will take on the series, and then description will take on from the assembly models, each and every model, and material also whatever we assigned for that, it will be taking here. I'll repeat this once again, because this is an important step to prepare the bill of material. So rpt.index we took from there. Then you click this. Name, we want asm dot name. Member, no? mbr user define. We have defined, no? Then so for this material names. The description. In this we choose PTC material name. PTC material name. So once you take this, update the table. Just update the table. So it will take automatically how many index is there. Accordingly, it will take number of index. So accordingly, numbers materials column also will be updated. So that is, this is what we did to do that. What I did. Go to update table. Automatically, you will get this all. It will take the instruction from this column and it will update the table. And switch symbol. If you switch the symbol, automatically you get it. From here, the formula applies. Description and PTC material. So corresponding descriptions material, everything is coming clearly over here. So go to layout, go to layout, general view, default. So now this assembly has come here. Default orientation is this one. So we can use these categories for drawing views, view display. So no hidden means it will show all this. Wireframe, non-hidden format, and visible areas. So the different bottom. This is the bottom, that is a top view. Hidden format, wireframe. So you can try it with a different format and see how this assembly looks. So some based on the vendor requirement, you will give the diagram, or the manufacturers may be requiring your diagram in particular way. Based on that, you will give your diagram. If it is isometric diagram is required, or top view or front view, sectional view, based on the manufacturer or the vendor requirement, we take that and give. So go to layout, So here we have got a lot of tabs where you work on for the drawing. So show model annotations here is useful to give the data line and tolerance and all. Show model annotation is very useful for it. So use this tool to draw, give annotations, tolerance, surface finish, and all those things. So annotations. So here you get the reference plane and then the distances. So it is you can go in for auto annotation also. Show model annotation. So what all to show in your diagram you provide. You are defining what all to show in your diagram. You define it, and now you can see the dimensions are displayed there. So you tick on what all things to display. As of now, we are trying to display the dimensions of all the parts. So our sheet is ready. So sheet is ready. The bill of material and the drawing showing all the parts. This is okay. Normally this will do, but in case manufacturing diagram should be detailed, you have to give many more details like that. For that there are many details manufacturing drawing like maximum material condition, minimum material condition, tolerance, surface finish, and many details have to be given for a manufacturer generally. But as of now, we are got a drafting system. We have defined only the basic details now. So we will continue this. So hope you are seeing my screen now. So it's a flange coupling. Flange coupling. I'm showing you the flange coupling here. So we are creating we are inserting this flange coupling in a drawing. Go to the file. We are taking a drawing and then naming that drawing as a flange. And we use a suitable format whichever you want, what size of paper, what orientation provide. Automatically it takes the front, top and side views. Go to table and we select the table and we take 3 columns of it and keep it here. And click the first column as we did, serial number. Next we click and give the description of it. Material properties, width, height and width, We are defining the height and width as we do it for the previous drawing. So as per our convenience, we are defining the height and width. Now we select this row and right click row and right keep it there and add repeat region. Add repeat region, switch symbol. This is what we did the last. Switch symbol, automatically your red box will appear over here. Once it is appearing, you will have three region to define what should be given here. Already we have given the material properties and all. So index rpt.exe, description, again assembly member user defined, because we have given the description user defined. So here also you are calling user defined. The description symbol text is description. So assembly member description, what description? So description also we have provided in the input. So material PTC material you have to give. Okay, this also you should remember. Already we have done once, but PTC material take PTC material name, PTC material name. Okay, once you take it, it will be assigned here. Now update the table, automatically the table will fill. We have got many parts in this diagram, so accordingly it will take the rows. Update table using this only, switch symbol, automatically the already assigned properties, the description and the material name will come here. Already we have done entering this all, that's why it has inputted here. You have to do that step initially before we start this step. Okay. So we can name it, if you want we can name it top view, front view and side view. Okay, so we can give the name of each and every part as we like. We can even change the text using this icons over here. Font size you can change. So go to the table and we can take one cell alone to write the description of the above diagram. This is a side view, so we write it here, side view. So I am changing the font for your convenience. So we can change the font and check. So as we require, so we can increase or decrease the font size too. So we create the table, another one table using this tool, and we create name, register number. So this is what we are using it for typing. Name is flange. So we can type your register number also. So you can do this way and submit your assignment. That will be very nice, so that to identify your part, that is your originality. So if you can, as soon as you finish the drawing, you submitted it this way with your name and register number. This is the way you should submit in your exam also. So now we can practice now during the assignment itself. We can practice those who are not. Still, you have not submitted one or two assignments. So those who are not submitted, you can start submitting in this way. So we are going to general view, general view, default all. So if you click your default, the default exploded view will come here. So default here you get back, bottom, front, left, all orientations. You can, if you want to take it inside, you can do this. General, no combined state, then it will come. It will be in assembled. If you click the other side, the other option, it is exploded. If you click this one, you are getting it like this. Default orientation. Yeah, we are providing default orientation. So this is a side view. You can annotate as we did last time. Go to annotate, show model annotation to show the dimensions. So you can choose what all it will show. Default should represent what all to show. You can tick on to get those dimensions. Show model annotation. You should go to show model annotation and then annotate. Show model annotation. This is a tool. Use it. So apply which dimension to give. Similarly, do it for all the views to get the annotation for all the views. Can name for this model also. You can name it's as isometric view or assembled view. Isometric view. So the sheet should contain the bill of material, the different views of the material, if possible isometric diagram, and the name and the register number. This is what it's expected when you submit the answer in your drawing and your answer for the examination. These all things is as expected. Or when you are checking a drawing from a company or a vendor, or you're giving a drawing to the vendor, this is what the people expect. Okay, so you should know how it should be and how to create a sheet, drawing sheet. So scaling. So we are clicking this and left is showing this view, and default orientation we apply, it will come to the isometric position. Okay, hope this will help you to give scale. If you want to represent the scale there, you can give the scale. You can increase the enlarge the image by a custom scale option. You can provide here. Okay, see here 0.800. So it is again, it has expanded the diagram a little bit. So 0.300 does become small. This is a very good option. So hope this will be useful in creating a drawing and creating a bill of material, and hope I hope everyone will do it and practice it so that it will be useful to draw and this is very useful since once the assembly is done, this is directly imported to the analysis. The properties are there, so constraints you can impose and you can start doing your operations easily. So, so we'll finish this part of the uh, demonstration.